I know it's early in the morning, so I appreciate everybody coming out. Just want to introduce our colleague right here, Andrew Holbrook, who is a postdoc researcher at the Stanford Medical Center and also a visiting fellow at the University of Edinburgh, and has been a big user of our NEO cross-platform app development framework in his work in MR imaging. So without further ado.
Thanks and good morning. If I stand like this, I guess you can still hear me. Thank you for the introduction. So today I'm going to discuss cross-platform imaging in room and around the globe. So how can I start this? Yeah, there we go. Thanks. Does this work? So just a little bit about myself. I work at Stanford University primarily as a research associate in the Department of Radiology, and on the side I also work as a visiting scientist at the University of Dundee, which is pretty close to Edinburgh, about an hour north in the United Kingdom. I am a medical physicist by training, so I did a PhD in bioengineering at Stanford University. And sort of by necessity and by kind of satisfaction, and I guess I just enjoy it, I've sort of become a developer, and more specifically these days, I guess a web developer. Today I'm going to discuss a few different topics, and I'll start off with what is the research that I do in interventional magnetic resonance imaging. And I'll discuss some of the applications I did, particularly in my PhD work related to this field. And then I'll discuss the transition that I've been making from making compiled applications for these different applications within iMRI to ones that would be using the web. And then finally I'll go over NEO itself and how I've been taking advantage of that for development and application design. So the field that I'm in is basically image-guided therapy, and it's as obvious as it sounds. So if we're doing a therapy within the body, and we're going to be using imaging completely along the way to guide this. So we would have imaging that starts with assessment. So what will we treat? What will we not treat? What will we avoid? And how will we get there? So how will we deliver a dose or an object to the place of interest? And then while we're doing this, we can use imaging to see how we're doing, to see are we at the target, and then when we're at the target, are we ablating or destroying the target? Are we poking it? Are we at the right place to take a tissue sample? Those sorts of questions. And then finally, when we're done, we can assess technology, or assess the therapy. We can see how successful were we, how much target is left if we, in fact, were trying to destroy that target, and then also if we were trying to spare something else, did we damage anything along the way? And in our group, we use magnetic resonance imaging for this, and MRI is a fantastic imaging modality with really amazing flexibility, both on the clinical side because of its exquisite soft tissue contrast. With MR, you can program the scanner such that you can get really really great contrast between, say, the liver in this case and the muscle or skin or fat, air, and also comparing normal tissue to abnormal tissue. So combine that with the ability to visualize devices, both actively and in the sense that you can stick a device in and it might be bright in an MR image, but also passively you can stick a device in and it might be black. So you might be tracking a void as opposed to an object or seeing the object itself. And then finally, it's temperature sensitivity. So with MRI, you can heat part of the body and you can watch it heat up in real time. And you can visualize an ablation as it's happening within the scanner. On the engineering side, it's inherently capable of 3D imaging. So with an MRI scanner, I can take a slice through the body in any orientation that I want. And that's pretty unique compared to other imaging modalities. And it's capable of very fast frame rates. So we might think of an MRI scan as being something kind of long, maybe taking minutes to acquire. In reality, you can actually do scans much faster than that. So kind of the bleeding edge research is collecting images, say, every 15 milliseconds or so. The work that I do has typically been around, say, 3 frames a second. So that, for me, is real-time imaging. So we can combine MRI with something to heat. So for instance, this is actually all three of these here are high-intensity focused ultrasound transducers. And these are ultrasound transducers that are not used for imaging, but instead are used to deliver heat within the body. And kind of like a magnifying glass can be used with the sun to focus the sun's energy on a leaf or an ant or something like that, you can take ultrasound energy, you can time it as it's coming off this transducer and creating deep within the body a time when all of this energy reaches the same point at the same time, and then that energy can be transferred into heat. And if you deliver enough heat for long enough and hot enough, then you can kill tissue there while sparing tissue, say, in the far field or in the near field here. And so what you have with this technology, with high-intensity focused ultrasound or HIFU technology, is a means of ablating non-invasively through the skin. And it's being used, it's FDA cleared now for treatment of uterine fibroids, for treatment of bone metastases, and there's many different research fields that use it. For instance, this is a brain transducer. So yes, with HIFU you can actually be treating tissue within the brain, even through the skull. So you have the heat side where you're applying this energy, potentially not even with a device in the body, and then of course you can have a device inside the body that you would be following in an interventional procedure. And then often they can actually be a bit of both. So two of the areas of interest, especially during my PhD, one was using a transurethral ultrasound applicator for prostate ablation. So the device was actually the one over here on the right. This was stuck up the urethra, and this ultrasound part right here is put right in the prostate, and then from there you can deliver ultrasound energy to destroy the tissue. And so this can be used for treating BPH, and we can then monitor it with multi-slice temperature imaging. And so this software here, this is just an early example of this software where I had 5 different images that are being collected throughout the prostate, and then they can be used to monitor heat. And not just that, with this software that was created, you start with sticking in the device, you then do treatment planning in it, and then you can do ablation and monitoring it and actually controlling the power that's coming off the device. And then in another project using that, going back 2 slides, going back to this transducer here, this is the HIFU transducer, using that for treating the liver as it's breathing. And in this, it's a very complicated system where you have, in this case, this is a pig. The pig is attached to, has a respiratory bellows sensor, so as you breathe, you get a signal that changes with breathing. And the HIFU transducer is set such that as the liver is moving, it is actually steering, and the focus of the transducer is moving up and down within the liver. And so both of these systems, they sort of combine the aspect of the MRI as well as this other technology, whether it be a device like the transurethral device or the HIFU device, and being able to combine these systems together into kind of one complete package for providing these different therapies. And in order to do this, interface is extremely important, because since these are very complicated systems, it's not just sticking a person in the scanner and running a sequence. These interfaces need to be very intuitive to be able to use. For one thing, if it's intuitive, it's easier to train. And for us, because these therapies happen maybe monthly or even longer than that, it's harder to remember if something is harder to use. So the more intuitive a user interface, the easier it is to remember for training. And so just an example, this is some work that I do for sleep MRI, so imaging people while they're sleeping. Yes, it's that exciting. That we do for looking at obstructive sleep apnea and seeing where we should have someone have surgery after watching them sleep in an MRI scanner all night. That interface is set up such that we can change the slices in real time. So if their head moves during sleep, and it's all set up to run with a multi-touch enabled system. And so by making it like that and using these intuitive gestures to control the scanner, it's easier to come back and remember if we want to do it months later. And so with that, I'm also always interested in how can I continually assess new technology to see if I'm using the best out there, and then if something else is out there, how do I implement that into my systems? So about 1.5 years ago, this would be the state of what I considered to be IMRI. On the study side, you would have multiple players, so in a treatment. For instance, I might have a radiologist, an MR technologist that's running a scanner, and an anesthesiologist or a veterinary technician that's making sure a patient or an animal are okay on the table. And they're all decision makers in this process. And so they all should be able to say, okay, yep, we can continue to treat, or no, this is a moment where we should stop, or this is where I want input. And besides them, there's also an external interest. So for instance, for some of these procedures, I'm not there. I might be in Scotland instead of being at Stanford, but I would want to be able to monitor a treatment and be able to provide my input other than via instant message or something like that. However, the software is single user, it's single PC or display, potentially mirrored in the Magnet room, and it's an isolated design. It's only this one user has control sort of system. And so my thought is that this software was not aligned with the workflow of what I consider to be the interventional procedure. And because of that, I asked these questions. Is a single user the most intuitive and useful interface design for interventional MRI procedures? And what are the advantages of designing if we kind of forget that and instead go to a multi-user medical imaging system? So there's sort of two separate ways you can look at this. We can look at the bore level. So if we're not constrained to a single PC that is typically outside where the MRI magnet is, we could then potentially have interfaces and means to communicate and control things at right next to the scanner table, and then across the globe. So I could be in Scotland and be able to control something or interact with the system. And at the bore side, there's some big advantages, for instance. So setting up the patient, being able to control how, checking how we're connecting different inputs to a patient, and being able to see how they're connected in the software and making sure everything's okay. Procedure control. So if I'm sticking a needle or something inside of a patient, then it's better if I have all the controls I want right there at the table versus having to, say, communicate to someone in another room. And then I don't know if this is true, but I think there might be comforting effects. So if I'm a radiologist, wouldn't it be better if I can treat a patient and actually be right there at the table as opposed to being a wall away in another room, potentially with no mirror and really no means of communication other than a microphone that you hear in the scanner? And then across the globe or anywhere, having external control, being able to maybe not control but help out and provide input on key steps in a procedure, and then looking at data after a treatment happens. And so what this is leading to is a collaborative or a cross-platform MR system. And it's not just that I want a single PC going to multiple PCs, having that ability. But I want connectivity across the full spectrum, from something that is as small as a mobile phone to something in between like a tablet. And this is because not every user needs the same features. If I have a vet tech or an anesthesiologist in the room, maybe I just want something that's as simple as a button that says stop because the patient's not ready, or some sort of lock that says, yep, you can't even do anything until I say it's okay. And that might sound trivial, but in some of our procedures, these procedures can be very stressful, and you might not always remember to communicate effectively with someone that's in another room. And traditional laptops and desktops might not be necessary for every task. And the other thing is, even though there are all these great mobile devices and tablets, et cetera, being able to design for mobile augments and can improve an experience. It's not like we're just trying to remove this. We're trying to add to this if it makes sense. And each platform has its strengths. So for instance, a phone, if I'm going to be guiding a needle into somebody, if I can have a single hand mobile device that I can control with a thumb, then that's great. That'll be very easy to use right next to the table. Or like in this case, this is at University of Dundee, they have a tablet set up such that it's kind of connected right to the table here. So they have much more real estate than, say, a tiny phone. And it's a little bit further away, but that's another sort of strength for that system. And then finally, when we need a lot of space, a lot of performance, and probably the most precise, so would say using a mouse for defining treatment zones, that can be outside the control room, or outside the scanner room and, say, in a control room. And so initially I started doing some of this development with some WebOS devices last year, and these are just example applications that were made using both the touchpad, HP touchpad, and then actually this is a Palm Pixie Plus device. And so these two applications here were created such that I could control the MRI scanner, whether I was right next to the table or in my home, for instance. And then this is an example of that respiratory signal, so connecting something and being able to visualize the breathing up and down. And so these were very functional, and I'll explain a couple cases in the next slides. And I'll come back to this idea that it was limited to WebOS, that it must have been compiled and installed on each device that I was using. This is one example of something I really liked, and this was a HIFU coupling test. So in the liver procedures, I have a transducer, I have the patient. You have to take the transducer and put it on the patient. And you need to make sure that device is coupled, it's connected between the transducer and the patient. And there is this one test we can run to sort of verify that this happens. And it was extremely cumbersome because I'd have one person that's holding the device, giving you a nod or a stare or something to run the test. You would run the test in another room, and then that person would have to communicate back to the other person about how good these results were. With this, instead, I can be running the whole thing. I can be placing the device, I can be hitting the button on my tablet, it will run the scan, and it'll provide the results right to me, right in the Magnet Suite. And so I can be the decision maker, I can decide everything and change where the transducer should be, all without having to move, and that's great. On the other side, having a physiology viewer allows me to move. So with this application here, I can check all these different physiology measurements wherever I am. If I initially set up a patient outside the MR scanner, I can do that. If I then put the patient on the table and I want to make sure everything is still connected or I have to reconnect them, I can do that again. And then finally, when they're in the magnet, I have a means to watch them wherever I am, whether it's in the control or elsewhere. But there's this risk, and I mentioned it a couple slides ago that I had to compile for WebOS for these applications, and if I had to put it on another device, then that would be something that I'd have to constantly do for each of these sort of systems. And if I wanted to move away from WebOS or move to being something that's sort of more generic, I would have to learn all these other different development languages. So JavaScript and C++, fine, okay, that's not that bad. But moving to Java, for instance, or Objective-C. On the desktop side, I program in Qt, and so that actually does a pretty good job of being cross-platform across PCs and Linux and Apple. But at the same point, the deployment aspect, that's something I was never really strong with. And the fact that I have to deploy, say, applications to sleep surgeons and things like that was something that it just wasn't a fun process for me. So instead, why not use the web? Instead of designing for a specific device or platform, why not just design for them all using modern web technologies? Why this would work? Well, for one thing, the thing that I really like is that users have a website or a web application to install, and that's really it. I don't have to constantly sort of check with them to see if they've had issues installing software. And for me, it's a single code base for all of these different things. Performance-wise, when I started with the WebOS project, I actually started in JavaScript, and it was really slow. So then I had to switch to creating the code in compile code. And then I guess that was sort of my like Zuckerberg moment, that I just couldn't do the JavaScript very well. And then I came back and I realized that I just wasn't coding very well. And now the JavaScript performance is fine for me in terms of being able to do these imaging projects. And so with proper coding, the web can be generally as responsive as, I think, compiled code. And then on the security side, you can have firewalls, you can have encryption, you can have various like user login accounts, and then on the server side, you don't have to send protected data if you don't want to. So I can store all of my data on a server, and then when I need to send an image to somebody, I can just strip it of all potential protected health information and just send that image. So it's ideal for systems that are for people that are trying to use their iPad, for instance, to connect to something, but a hospital might not really like that, might not like the fact that you're installing applications on a personal device. So the data doesn't leave the system unless you go through all these different hoops, and even then it's very kind of minimalist in what it will be sending to that user. But there's still a risk, and that's the same risk, just packaged a little differently, this fragmentation. Operating systems can be different. Browsers on different operating systems can be different, and it can be a bit of a struggle to navigate all these potential different options. Or even if you just want to have one option for each of these different systems, being able to code for them is still not particularly easy. But I think it's better than the other sort of fragmentation because web standards are causing browsers to converge as opposed to diverge or stay split. And so what happens with new browsers? Well, you get better performance or better GPU performance, and you get more implementation of HTML5 standard features. And then event handling, this is another one, event handling I think is getting easier and kind of converging as well. So in order to navigate these different platforms, I would say, it's important to have a good cross-platform strategy. And so in terms of web design itself, I want something that's easy to visualize things, so I can take things and not have to recreate every single aspect of a website. I want to be able to handle mouse events versus touch events. I want to be able to do all this without sacrificing performance. And then on the application design, because it's not just, say, a website, I want to be able to structure things such that I can organize and attack my development in some sort of logical way. Because I don't want to have to recreate everything that I do. I want to be able to create one application and extract the important things and move it into something else. And then finally, is this feasible while being custom, beautiful, and intuitive? And so I've been using Enyo now for, I guess the last 11 months specifically for pure web design. And one of the things I like about it is it does allow me to design once and deploy almost anywhere. And using a supported modern web browser, you can work across many different browsers. And this is, I think, updated as of last week, showing all the different Tier 1 supported browsers and platforms. And then these are the Tier 2. And just for reference, the ones that I use are typically Linux for Firefox and Chrome, Android, Chrome for my phone, and then I have an iPad that I test on iOS 6. So going back to that fragmentation, this is a software solution that is aiming to solve it, especially when there's still quite a few differences between these platforms. I like, because I can design on anything, I just use a text browser or text editor and a browser to code my projects. And that's great, because that means I don't have to buy another type of computer for every sort of system or have all these different virtual machines to run everything. It allows me to focus on my project and not various ports of the project. And that it can be simple and powerful, because it's a modular system, it's very easy to organize things, but at the same point, if not everything is there, it's also easy to implement other web technologies. And over the course of the last year, I've been working on 4 different projects, and these are all in various stages of development. And I'm going to briefly go through what some of these applications can look like by using this system. The first one here is my first one, and it's a MR-guided HIFU in a web browser. And with this, you can do real-time MRI control, so scanning, I think, up to 3 planes with your browser or with a tablet, with an iPad. And you can adjust the planes as you wish, like adjust where you're acquiring these images, and then you can actually control a HIFU system. So I can let's see, this runs. I can click somewhere on one of these images, and then I can say I want to ablate there, and I can dial up or dial down the power, and I can visualize this ablation happening as it's happening. This is a little bit of a slower frame rate. It's not the 3 frames a second I was mentioning before, but we can have multi-slice visualization of this heat, and then the temperature is shown by this overlay that's going to show up in yellow, orange, and red. And actually, I can show this to people that are interested later. It's kind of a long, slow video. So if you want to see this in its entirety, come find me afterwards. But the main idea is that these are all different functionalities and capabilities that I was doing in compiled code beforehand. And now I have a system where I can do this, and I can visualize this, and I can do it across systems very easily. So when I am doing these tests, I might have the large Mac computer that's running right in the control room visualizing this, and then I can run it on my laptop as I go in the electronics room to make sure I'm not breaking the HIFU system. And so it's very easy for me to have these separate systems and yet still have sort of that control on each of these, individual control on each of these systems. And that's what I really like about this system. Another one that I'm working on is something called on-patient imaging. So I mentioned we have a transducer we're placing in the body. It's not always easy to put it in the right place if we're trying to treat a specific target. So this software here allows for a 3D visualization of slices such that we can see as we're moving a target or a transducer around if it's in the right place before even entering the magnet. And then there's an additional separate interface that we collect all these different volumes beforehand that we can then load into this viewer. And this has been tested all from the PC all the way down to the phone size. And I like it because it's intuitive and snappy on any device because it's taking advantage of these CSS 3D transforms, which are really great, but they have one flaw, which I'll come back to at the end. This is another one, a sleep MRI project. This is, again, that project from beforehand. This is a means to visualize that data using Enyo. So in this case, I have a collection of images that were collected during the scan, as well as a physiology data that's also collected. And then this is, for instance, the entire study of this physiology data. And this is designed to sort of be like a sleep study software that someone could then go in, look through, score, mark where certain respiratory events are, and then later someone like a surgeon could come in and review it, look at the areas of interest, and then see where to treat. And it's primarily PC-based for the current time, but there's really no reason it couldn't be scaled down into something else. And I love this because this allows for gigabytes of data to be left on the server. I don't have to have people constantly downloading data, and they're only accessing what they need to. So these images only show up depending on what current time point they're at. And it's just easy for all users to access, even remotely. And this one's very much a work in progress. I started this about a month ago, and I'll just briefly mention this is for placing a device in a prostate, placing a needle and guiding it to a target in the prostate. And this is going to be designed to not just work across the spectrum from PC down to phone, but it's going to have different features for each one. So for the phone application, a lot of the functionality will be sort of reduced to what you can do blindly. So if I tap the screen without looking, then that'll start the scanner. I tap it again, it'll stop the scanner. And so sort of functionality like that that'll allow for very simple controls for the radiologist, but at the same point, if they have a tablet in front of them, a means to visualize that. And so there'll be that, as well as this collaborative treatment planning. So if we're again marking where we want to treat and where we want to avoid, someone else can do that. For instance, I can have the radiologist could have been collecting those images, and then someone else can, or many people can come in and help define these regions. And so that would be, I call Google Docs for interventional MR, being able to mark all these different regions together. So that's just a brief overview of the 4 projects that I'm working on right now with Enyo. And just I want to go back and discuss why Enyo helps facilitate these designs. And so if you remember this slide before, for content visualization, there's this great thing called this Onyx sampler. And I think Dave's going to discuss it in a few minutes. And when I'm starting, when I design something out on paper, then I just sort of go to this website, enyojs.com/sampler, and I find the things that I'm looking for, and then I steal them. So I can hit the button, I can view the source, I can then actually view it in JS Fiddle, and I can play with it. I can make it exactly what I want it to be like, and then I can insert it in my code. And so I can do that, and like the touch events and the mouse events. When I started with my sleep project, I had to make my own driver for my multi-touch monitor. And with this, everything's sort of handled, and it's handled like a mouse as a touch event, and that's makes it easier for me. And then finally, performance-wise, the browsers and systems can make a difference, but they're generally similar across platforms. And sometimes I've had problems where something is slower when I put it into my software, but then I go back and I check in the sampler, and if it's fast on there, usually that means it's my problem as opposed to something within the library. In terms of design, I like that I can have various design strategies. So for instance, I can have a scaled design where I take this, if this is my starting application in Chrome, if I go down to smaller, different screen sizes, I'm just using percentages basically to visualize how information looks. I might have some little checks that say take this title and make it a little bit shorter for this thing. But in general, I can take an application and scale it to whatever device I have. Similarly, I can do the complete opposite. If I want different interfaces or different looks for different sizes, it can be just as simple as for some of these objects, for instance, just taking a class and removing it and adding the small class instead of the large class. And then what that will do, for instance, is like this. One of these little buttons here actually enlarges to this view right here. And this one, it might on the top one. My battery is dying here, but on the top one. It might be one of the, it might take up the full screen. And so having this ability to just adding and inserting classes with a little bit of code, that is very helpful and I guess much more clean in terms of coding this up. I like that it's modular. If I take this sleep application, I have many different kinds of parts here in this application. I have the entire application itself. I have the imaging card, I have this physiology card, and then I have this events card. And all of those have their own different types. And so all of these things are different little JavaScript files that I can then keep compartmentalized. And then I can create things on the fly, and orange or red doesn't show up well on black here, sorry, but you can dynamically create things as you need. And that's important for me for imaging because I want to be able to prescribe 3 slices or 5 slices or 15 slices, and I don't want to have to know that before I even start. And then if I do prescribe 3 or 5 or 15, it's very easy to connect. And they say not to use this a lot, but I love it. I love this I knew signals thing because I can dynamically create something and I don't have to physically then go in and reconnect every single part to this whole application. That's wonderful. And so finally, does this allow me to create applications that are custom and beautiful? They are certainly different from each other, and at least to my eye, I find them quite pretty. And are they intuitive? Well, that's really my responsibility. Now that I have these tools that can create something and sort of create them as I want, it's my job to make sure that they work as a radiologist would want or someone as part of our team would want. There are frustrations, however, and as I mentioned, that not all browsers embrace HTML5 completely, and technologies aren't necessarily cross-platform. So, for instance, WebGL is utilized by this 3JS library, which I like. But it's slow on tablets, primarily at Apple, because there is no WebGL in Safari. So then the alternative is not that great. However, CSS is wonderful, especially on iPad. It's extremely snappy compared to WebGL. However, on Chrome and Firefox, there are these bugs that basically screw up how things are looking in 3D. So if anyone knows anyone in Chrome and Firefox, please tell them to fix this. And NU is not perfect, but it is actively developed, and so there is a mechanism for reporting bugs that you might find, for asking the questions that you think a community could be helpful in answering, and then also connecting with some of the developer relations people to ask the questions you don't dare ask in a community forum that will help you code these projects. And so kind of coming back big picture here, what does NU allow? It allows me to use these great tools, this Onyx library, as well as some of the other layouts and other functionality that's built into this library. And then that allows me to focus not on the components itself, but how I want to integrate them, how I want to build them into my systems. And it lets me design for the web. And then by designing for the web, I can take advantage of the really beautiful, intuitive design that the web allows, and then also have a single code base. Allows for multiple platforms, and then very easy deployment and distribution. And I haven't mentioned this, but coming back to that idea of being able to continuously iterate, with this system, I can rapidly expand to other devices. So, for instance, a few months ago, I decided to see what would happen if I wanted to use a Nook in an MRI scanner, and I wanted to see if I was okay with black and white. How would that look right in the bore? I could just take a Nook, root it so I could get to the browser, and then I could create a very simple application to run in that browser, and then test this, have this proof of concept. So with this, it's really opening for me this ability to have these collaborative interactions, making them possible, whether it's just getting through that wall that's between the MRI scanner and the control room or across the globe. And so I just want to acknowledge our group. So my supervisor, Kim Butts-Polly, is a professor at radiology at Stanford, as well as Andreas Meltzer, who is a professor, I think, in radiology at the University of Dundee. Some colleagues at Heart Vista, which is a real-time MRR startup, and Insight Tech, which is a HIFU system developer. Some grant funding from both the U.S. as well as from Europe, and I want to thank HP for sponsoring this trip here and this presentation, the invitation from Julie and Enda, as well as development questions from Arthur, who isn't here, as well, and Dave Freeman, who is going to be speaking next. So I thank you for your time. If you have any questions, my email address is aholbrook@stanford.edu, and I'll be here after Dave talks. So thank you.
Thank you, Andrew. If we can get the other slide deck up. There should be a second one. There we go. So I'm just going to talk a little bit about the INYO framework itself and go through some high-level stuff, and then after I go through the slide deck, I'm actually going to show some things on our website, the sampler app that Andrew mentioned, and then I'm actually going to show some very basic code examples. So if we've got some developers in here, that'll be the interesting part for you to see how INYO is actually driven. If I can figure out how to use the button. There we go. So INYO is a framework. It's a JavaScript application development framework that is, as Andrew mentioned, cross-platform and cross-browser. We want to make sure that JavaScript developers can easily create these applications and get them deployed to as many potential endpoints as they possibly can. So on the desktop side, I think I have a slide on this later, you can run INYO apps on IE8 and higher, Modern Mozilla, Modern WebKit across Windows, Mac, and Linux, and then on iOS 5 and 6 and Android 2.3 and higher. So you've got a really broad device ecosystem that your app can run on with just a single code base. So again, truly cross-platform, optimized for mobile. Our component model lets you manage complexity, right? So everything is contained in our, encapsulated in our component model, and I'll go into that whenever I show some examples here in a minute. Another good thing about INYO is that it's Apache 2.0 license, so it's open source and free, not just free for cost, but free for you to take and do whatever you want with it. All of our development is in the open on GitHub, so you can fork our project, make it your own private proprietary version, things that you want to do to it, and we won't care about that. We just want people using our framework. We do like people to recontribute back into the project, so we accept pull requests for bugs that people find or features that they think should be added. It's extensible, community-centric. We do have a growing community of INYO developers that like to help each other on our forum site, as well as IRC, Stack Overflow. We try to touch as many places that developers go for questions as we can. Excuse me, and it's lightweight and fast. INYO core, I think, clocks in. I have to check because we just released a new version last week, INYO 2.1.1, but the core should be around 30K minified in gzip, so it's pretty lightweight and doesn't have a lot of extra things around it, just to give you the basic component model. Let's see, you want to use INYO if you want to write apps that will run on all types of devices across multiple platforms that have native polish and performance, and code that's, if you want to write code that's easy to maintain and reuse. One of the strong points about the component model is that you can, once you've developed a particular component that provides some functionality, it's easy to take that and put it in another location in that same app or in a completely different app, right? So you can reuse your components very easily with INYO. Why would you use INYO versus straight HTML5? So a question I get a lot is this HTML5? Technically, yes, because it runs in these browsers that support HTML5, okay? But at its heart, INYO is just straight up JavaScript, okay? So it's easy to code if you're a JavaScript developer, and it's compatible, like I said, with various browsers across desktops and mobile devices. We've done a lot of work trying to get scrolling performance, the same across these multiple devices. If you come by our booth later today, we've got it's like a Kindle Fire where you can see our big, 2 million entry scrolling list with no hiccups, and see it running on an iPod or iPad. I think we got an iPod out there, an iPod Touch, so you can see it running on these various devices.
And the Onyx widget library, which is an add-on piece for Inyo, provides a lot more styled components. So if you want some pretty pickers and things like that, those are available in the Onyx widget library. So we've done a little bit of work of polishing up your standard HTML elements. Another question we get a lot is, how are you different from Sencha? So one of the things that differentiates us is the fact that Sencha really has two frameworks, one for desktop and one for mobile. And the developers I've talked to, tell me that, say they started in the desktop world, now they want to bring their app to mobile. Well, it's almost impossible to reuse the code that they've already done on the desktop, and they kind of have to rewrite from scratch, and the same vice versa. If a company has started in mobile space and then they want to take their app to the desktop, same thing. They have XJS for the desktop and Sencha Touch for mobile. Sencha's licensing model does give you some freebies, but at some point when you get to a high number of seats, then you have to start paying license to Sencha. So we win there as well. Again, we're extensible and community-centric. From what I gather, Sencha has minimal community participation as far as contributing back to the core frameworks that they provide. Unlike us, like I said, we do actively encourage people to contribute back into the Inyo project. Another question we get is, what makes you different from jQuery? So in my view, jQuery is more about enhancing existing web pages, not necessarily providing a framework for full app development, right? Versus Inyo, we give you the tools to build an entire web application from scratch that's going to be delivered across whichever browser or environment that you want it to run in. Excuse me. And doesn't necessarily facilitate native like app UI. What else do we got there? That's good enough for that slide. How can Inyo apps run anywhere? So we've, like I said, done a lot of work getting scrolling performance the same across multiple devices. Our list system uses that same scroller. We can get good performance based on our the way we handle lists is kind of a virtual paging system. You really only have 2 pages of the list of elements available at any one time, and as you scroll, it renders more elements and takes others out that aren't viewed. So it makes everything very snappy and no lag when you're scrolling. We have a couple of components or libraries, if you will, that augment the core. One is the layout library, and it provides a component called panels, which is a responsive design component that will, based on the viewport width, will either show all of the panels or will only show one panel if you have smaller screen real estate, and I'll show you guys an example of that in a minute. That would be one of those adaptive widgets. We have a more toolbar that kind of does the same thing. It'll outline all the buttons that you put in the toolbar, but if you're in a smaller viewport, it'll take some of those buttons and put them under a little ellipsis drop down. So you can have the same exact code running on these wider viewports on the tablet or the desktop, and then on your phone, you can still get to the same options. It just displays them a little bit differently. And swappable modules. You may not need to have the layout or Onyx widgets. If you just want to do some basic component stuff with Inyo, you don't necessarily have to include layout in Onyx, right? And we've also got some new modules that came in 2 releases ago for G11 for some localization. And what was the other one? We're starting to add in our new MVC and data binding. That's not necessarily in the released 2.11 the release code, but it is on GitHub. So if you go and check out our GitHub project, you'll see the work that we're doing on the MVC and data binding side. All right, and I added this slide a while back just to give a brief history lesson of how we got where we were. So all of this came from Palm's WebOS. So if anybody's familiar with the story of Palm, they came out with WebOS in 2009, released the Palm pre-phone, excuse me, and the app dev framework of choice at that time was called Mojo. It was another JavaScript application development framework, and it was designed by Java people. So it was pretty clunky to get your mind around if you wanted to write straight Mojo framework code. And so a lot of us, spent a lot of time figuring out how to do that. So Palm recognized that it was a little bit more difficult than they wanted it to be, so they came up with a web IDE called Aries. and it basically allowed you to do some drag and drop of components and then hook up your JavaScript code to them, and then it would generate these Chrome components that would wrap around your Mojo code. By the time I had learned, I learned how to do Mojo before Aries came out, so it didn't do exactly what I wanted to do. I wanted to be able to take my existing Mojo code and then use the GUI builder to kind of modify things, and that's not exactly how it worked. But what they discovered was that Aries had this really great component model. So when HP came out with the touchpad, they also discovered that Mojo didn't scale well to a larger screen real estate. And so they said, hey, we got this Aries thing, it's all JavaScript based too, let's see if we can develop our framework out of what we've come up with for Aries, and that's how Inyo 1 came. Originally it was only meant to run on the WebKit instance that's available on WebOS, so it was closed source and proprietary, and like Andrew mentioned earlier, he had to compile apps and things to run specifically on WebOS devices. All right, so and what's happened now is that we have open sourced Inyo 1, but we don't actively develop it anymore. So if you guys want to use Inyo 1, you can put it on whatever devices it'll run on, but we're not going to add any kind of support for new devices or new browsers that come out. If you find any kind of security problems, then we'll probably address those, but we're moving on to Inyo 2. Once HP decided that they didn't want to make the touchpad anymore, we decided that we would open source Inyo, and now we have Inyo 2, redesigned from the ground up as this cross-platform, cross-browser solution. We also have, if you come by our booth and seen the little signs, we have a sister project which is Open WebOS. Since all of this came from WebOS originally, that has now been open sourced and has been 1.0 out of beta since early September, I think, so 6 weeks or so. So you can check that out as well. Excuse me. Oh, here we go. Inyo supports modern Mozilla, modern WebKit, IE8 and higher, Opera, the Kindle Fire, iOS, multiple Android systems, BlackBerry 10 runs on the playbook already. Coming soon for Windows 8, we're working closely with Microsoft to make sure that our stuff is running well in their new stuff. And we actually have a Microsoft Surface with us, so you can see in the browser at least the sampler running, the same as it does on all these other devices. All right, Inyo itself is designed as a component system. So you have the core framework. Let's use a little thing. There we go. The core piece of Inyo that gives you all of the component model stuff is in core. If you want some layout solutions like the panels thing I mentioned, and I think more toolbar is in layout and not Onyx, but at least panels and the fittables, things that will expand to fill space, are provided in the layout library. Onyx are the UI widgets that they're kind of more like a combination of components, JavaScript and CSS, so they're like composite controls that are provided with Onyx, and there are a whole bunch of different Onyx widgets that come with that. And then in progress, in progress is Aries 2. You can find that project also on our GitHub under Aries-project. It's not super ready for prime time yet, but you can follow along, download it, and see if you can get any functionality out of it. We've got a couple of guys in Sunnyvale working on that full time, as well as a small team in France that helps that. So things are happening quickly with Aries 2 development. So keep an eye on that. Excuse me, cannot get rid of my cough. And then finally, I've got a couple of slides from some partners that have been using Inyo for their solutions. I really like this one from Xtuple. We met with them last May at the Fluent conference in San Francisco, just before we went out of beta, and they came up to us and said, man, we really wish we'd heard about you guys 6 months ago, because we're developing version 2 of our CRM product using SproutCore, a SproutCore library. And they were very unhappy with how the SproutCore leadership team was not, kind of fracturing, and the community was not really helpful, and they just weren't, getting answers that they wanted from the development team, and they weren't happy with the performance that SproutCore was providing, et cetera. But they had, spent 6 months working on version 2 of their product. So they came and talked to us, and then one of our framework engineers, Kevin Schaff, went to talk to them a little bit more in depth later, and convinced them to at least give it a try, take Inyo out for a test drive and see what they could do with it. And Turns out they liked it so much that they just did their whole version 2 product in about 6 weeks with Inyo 2 versus the 6 months that they'd already spent on Sprout Core without great success. So Xtuple's great success story there. We also have OpenBravo that recently released a product called OpenBravo Mobile, which I believe is just an application that interfaces with their web POS system. They have a point of sale system that's drivable over the web, and then they have their mobile app to interface with that. They wrote that in Inyo as well. We have one more. This is an independent developer that's been around since the early days of WebOS, and basically he's been able to take his app and put it on 8 to 10 platforms inside of 2 months with just one developer and one designer. So once he had the one web app created, it was easy to put it on all of these different platforms and stores. So he didn't have to make any changes after that. Let's see what else we got. On the roadmap, I've mentioned data binding and MVC. That work is right now being done. You can check that out in the current nightly stuff on GitHub. Excuse me. We're thinking about what we're going to do with our next generation list and providing a grid control. We still are working on list performance. We want to make sure that everybody's happy with it. Win8, WinPhone 8. Excuse me, providing app templates to let developers get started more quickly, maybe with certain layout designs or certain components already included. More and better documentation, more widgets, and Aries 2. As far as developers go, we want you to get involved, try it out, give us your feedback, help other developers with questions that you might know the answers to, spread the word and tell people how awesome it is. Build and share your own Inyo add-ons. Oh, that's one page I didn't have up. We have a community gallery, so if you've created a component that you want other people to be able to use, you can add it to our gallery and they can download it. Last time I checked, we have 60 plus components available for developers to do just that. And then also we do, like I said, accept pull requests to contribute back to the base project itself. Stay connected. We have support at forums.inyojs.com. Email devtechsupport@inyojs.com. You can follow us on Twitter. I constantly have a search window in TweetDeck that looks for InyoJS, so any questions that you send there, I'm usually pretty good at least responding to those as I can. And then if you're interested in working on the framework itself and you're a great JavaScript person, then give us a resume at inyojs@palm.com. I think we're still hiring on developer relations and the core framework team as well. And that's it as far as these slides. Now I'd like to switch over and show you guys some, no, I'll do it right here. I think this mic's on. Show you guys some more technical things. Is this still on? Can you hear me? Good? Is that all right? I'll just talk loud. All right. All right. So this is just the main InyoJS.com site with docs.com. Let me kill. There we go. That may not work. All right. I just wanted to show you this. We've got a bunch of stuff up here, some docs and tutorials and samples that you can go through, some knowledge-based things, some more in-depth documentation on how scrollers and lists and things work. So check that out at your leisure. The API viewer is pretty good, and we're constantly adding documentation to the components. This reads all of the Inyo source code in real time and spits out documentation, so you can go and dig down and see how things are set up. Right now this is Inyo.control, so it shows you things like the properties and the methods that are available for Inyo.control. Let me go ahead and pull up this so you can see. I'll let that one roll. All right, so here's our gallery of components. So you can go in, and most of them will have a demo that you can look and see how it works or view the source. Most of these are actual components that render controls into your web app, but some of them are back-end things like local storage wrapper, and other, like JSON-P request wrapper. We had somebody write a web service classic before we came up with our own web service component. We were just driving Ajax straight with a new method, so he wrote this one, but we've since written our own, so they're about the same. But most of them, like I said, are controls that you can use. Let me find Peter's favorite one. There it is. Canvas spinner demo here. It's pretty good. So it gives you the ability to, change the color, the shape, and the speed and size, and what the range is of your slider or your spinner. So that's pretty nice. I like that one too. All right, so that was the gallery. Now let me go over here and look at Sampler. Okay, so like Andrew mentioned, you can go into the Sampler app either live, or you can download and install it on a device, and it gives you some samples of different things about Inyo. So in Core, you would have some Ajax tests. We can see if this is going to work. I think I'm going to be online. There we go. Get something back from Yahoo Query, or do it in JSON-P, or with a web service component. They're all basically do the same thing, just wrapped in a different method, either straight Ajax or JSON-P. Scrollers, so you can see, oops, that one, I'm going the wrong way. It will determine whether or not you're on a touch, by default it'll determine if you're on a touch device, and it won't show scroller bars, and it'll just be something that you can drag up and down. But on a mouse system, it'll show you little scroller bars. A repeater for simple controls to just stamp out the same control over and over and over again with different data. New gestures. I haven't tried this one yet. Oh, cool. So I can get my different gesture events and see what's happening. Let's go to something a little bit more exciting, like Onyx. So the Onyx widget set, this is what we provide. So buttons, various checkboxes and inputs and sliders and progress bars and things. What's really cool about the Sampler app is that you can hit this little button now here, Open Sample in JS Fiddle. JS Fiddle has Inyo as one of the frameworks that you can choose. So this will just take you straight to a JS Fiddle that shows that source code, and you can see it running over here in JS Fiddle. JS Fiddle is a great tool for testing, for quick testing Inyo components and code, and we're really pleased that they have it there. What else I want to show? Oh, let's see. Let's go back to layout list. So there's a basic list, and this one has only 20,000 entries in it. You can go in and modify that number of entries and have it. It used to be 2 million, but I guess they've cranked it back a little bit for the sampler now. There's one for Twitter. Let's see what's going on. Not a lot recently, a couple hours ago. You see that we just do straight up Twitter search on Inyo.js. So it's really great. This is new stuff, image view and image carousel, which is just a panels. Oh, that's what I want to show you, panels. Panels is one of our great responsive widgets. So in fact, this entire app is based on, it's a panels at the main component level. So that lets me do things like this left side is a panel, this right side is another panel, I can drag it over here, etc. What I can do is resize my browser window to be more like phone size. So once I get down below 800 pixels, it's going to do this thing where, oh, now it makes my left-hand side panel be full viewport, and then I get to the other one just by dragging it over here. So it's the same code, again, runs on the browser and the tablet with seeing all of the panels, while on the smaller real estate, you'll just see the one, and you can swipe between them. No code changes involved for that. You might have to do some little extra things like go ahead and automatically focus that second panel so users will know it's there and they can go back to the other one, but that's dependent upon your app design needs. I think that's all I want to show on Sampler. All right, so back to JS Fiddle. These are a couple of fiddles that I saved for demonstration at our last event that we went to at QCon. And just to show you some basic things about the core component model of Inyo. So, let me take a little drink here. At the basic, at the lowest level is Inyo object. All right, so everything extends from Inyo.object. We have a concept called the kind, right? And you can basically think of it as a class, but JavaScript uses class as a reserved word in JavaScript, so we've called it a kind. So we have this method, Inyo.kind, that you pass a JavaScript object definition to, and it will make a new constructor for you. It's basically a constructor factory. Excuse me. So here I'm making a new Inyo object that I'm calling expiration. And I'm telling it that I'm extending from Inyo.object. I can leave that out, and it will default to extending Inyo.control, which is something that renders into the DOM, but I want it to actually be an object. So I'm telling it what its super kind is here. And then I'm giving it a published property. Let me go ahead and run this because it takes 1 minute for the, oh no, it didn't. That was pretty fast. Let me reload that. I've given it a published property, and any properties that I put inside this published property get automatic getter and setter methods. So I have like set EOL and get EOL provided to me automatically by the framework, as well as I can provide a changed function that I want to run anytime I run set EOL. For instance, I'll run EOL changed if I provided it will get run automatically. So this is a very simple example. In the constructor for this object, I'm just going to go ahead and take any properties that I've sent whenever I've created this object later, and then we go ahead and run my any changed functions that are associated with this particular kind. So kind definition ends down here, right? That's the end of my Inyo.kind call. And now I'm making a new expiration object with an EOL of a minute from now. For some reason, it's running a lot faster than 1 minute, but when I run this, it'll say, oh, I expire, it's just running because I told it to run automatically. It's going to expire 1 minute from now. All right, well, that's not very exciting. So let's extend this a little bit more. So I have my expiration object here still. I've made a slight change where I'm not actually going to alert, I'm not doing anything in my EOL changed method now. But what I'm going to do is create a new kind. This one I've named mortality, and it's actually extending Inyo.component. Component is the next step up from Inyo.object, and it allows us to do things like contain other components and also provide events, Inyo events that we can listen for in our app. So I'm going to make a not published property, call it, by convention, this would be a private property called fate, and inside there I'm going to make a new expiration, which is my object up here, right? And I'm going to go ahead and set its expiration time to 10 seconds from now. And then I'm also going to provide an event that I want to be able to listen to if I include this component somewhere else. And I'm going to call it on expiration. And then in the create function for mortality, I'm going to go ahead and set up a heartbeat, an interval that checks whether or not it's expired, and then do something if it has. So if I run this, and running it is as simple as creating a new one, right? M equals new mortality. I'm going to run this, and then 10 seconds from now I should get a little pop-up that says I've expired. Maybe. There we go. So that works just fine. I've also sent an event. I've done this.do expiration. Any events that I provide for my component need to be named on something, and then whenever I want to fire that event, I say do something, whatever that event name is. So in this case, I say do expiration, and I can send whatever data I want along with that event. All right, so a little more exciting, but still not great. Let's extend it a little bit more. So I still have my expiration object. I've got my mortality component. And I'm going to make something that actually renders into the DOM, an expiring control. All right, so this is just a regular Inyo.control, which is something that renders into the DOM. Right? Components don't render into the DOM, but controls do. And since it's a component, I can include other things in it. Or excuse me, control is actually extended from component so it gets all of the same functionality as Inyo.component, so I can include other things in it. So that's my components block here. It's going to have a mortality component, and then some content that says I will expire. And then once right here, I'm listening for the on expiration event for my mortality component, and whenever it happens, I want to run my expire function. All right, pretty simple stuff. So if I run this, it should put something over here. It's content, I will expire, and then in 10 seconds, it should destroy itself. There we go. I don't want to go on the cart. All right, done. All right, and then the last extension of this is just making a extending upon expiring control. I'm going to make something called a coupon, right? So I have this coupon control that extends my other custom control, expiring control, and does things like this. Run this today only, get 10% off the price of Inyo training. 10% of free is free, so you guys are getting a good deal here. And then 10 seconds later, it's going to do coupon expired and delete itself. So again, very simple examples of what you can do with the component system, but you know, you can extend upon this and make some very complex component interactions, and then also be able to take each of these components. They're all standalone and encapsulated within themselves, and you can easily include these in other projects. You can also easily include them in existing websites. Let me show you that real quick. I've got my WordPress site here. This might actually be a little slower than I would want because I have been playing around with some new stuff. Should have loaded that one up earlier. There we go. So first of all, this is a new thing over here in this right-hand corner. This is basically an image carousel kind from our new library stuff that we came out with a couple of weeks ago, and I've made it into a WordPress widget where I can easily just go into the admin control panel of my WordPress site and include this widget or not include this widget, and it just runs my Inyo application. This could be any Inyo application. I had a simpler example here that just shows how to include Inyo in your the header of your template or your what do they call it, your theme for WordPress, and then in line write just any Inyo component that I want. This button is actually an Onyx button from Inyo itself. It just does this little tap thing. But again, it's very flexible on how you can use Inyo with other projects as well as other projects within Inyo itself. I think that's really about all I have. If anybody wants to go into any more depth on the technical side or look at some more code samples, I'm going to be at the booth until the session's end today, so I'm available for questions. We can open it for Q&A now if anybody has anything they want to ask. Otherwise, I think I'm done. All right, thanks everybody.